Right. Okay, so we are here talking to Dr. Cary Butler on the day that we're going to celebrate his retirement. And we wanted to sit down and talk to him and kind of get a retrospective of what his career was, all the things that happened to him, any thoughts he has about working at ERDIC. So to start off, let's talk about getting hired and the beginning of your career, like your first project that you had. Tell us about that.
Wow. So, one thing, kind of reflecting back on back in the 80s, it wasn't easy to get hired back then. Hiring was a big deal, nothing like it is today. It seems really easy. So to get a job out here, it was not the simplest thing. So the way we use contracting as a way to evaluate people. So I was one of my professors at Mississippi State took a job with a company out of Huntsville, and when I graduated, they offered me to interview. So I interviewed with them. I got the position. I was put on as a contractor here and worked 2 years to start. But it was, a lot of coding, a lot of new development that was going on. We were just trying to get involved in using computers to do modeling. Computer science was kind of unknown out here. So we started working on a lot of mapping technology and using models and reducing these big models that we had running on our larger mainframes back then, condensing them to something that we can run on smaller machines and get out to the field. That was their big emphasis coming in, and I think looking back, I was probably one of the first computer scientists that actually started out here. Most of the computer people back then were mathematicians, and I was this new computer science thing. It was really odd for waterways back then to even think what computer science people would do. So I started in October of '86, right after my graduation, and worked 2 years as a contractor, and then in the '80s got converted over to government, and that's kind of where it all started.
Right. So I came in like 6 years after you did, and when I got there was this already established team that you were a part of,
right,
that was just going.
Right.
So tell me about that team and kind of how all that came together and what you guys did.
Right. So some of the guys over in back then, it was GL. They had a vision of, we had all these codes running on our mainframe. Could we condense them and get them into PCs? The PCs were just coming in the market at that time. So the trick is that if we could get our models running in a PC environment, then we could get them to the field. And that's what they wanted to do, is make the impact on the field. So we started out, TC Falls, myself, I think we had Ben Webb, and there were some other guys over there, but that was the gist of the team. And we really tried to figure out what the art of the possibility was. Back then, there wasn't a lot of memory on the machines, not a lot of disk space. So we spent a lot of time playing games with how do we run codes that take a lot of memory on machines that did not have a lot of memory, things that we really don't even pay attention to today in today's programming. So I think that was one of the big challenges. Mapping, everything that we did over in that area had a spatial component to it. So mapping was a big deal, and how we deal with these big, mapping data was big back then because, we didn't have big disk drives and stuff. So getting very creative with how we stored the data and how we were bringing the data off the disk. Really, in modern programming, most of that you don't even worry about anymore. Mm-hmm. But there was so much attention given to that back then, because if you really didn't pay attention to it, the end product wasn't going to be worth using. So.
Right. And so most people today, if they wanted to do mapping, they would use something off the shelf. But you guys were not using anything off the shelf.
No, I say all the time that we were in C. We started everything with a VI a blank VI with pound include stdio.h. That's everything. I mean, we started from scratch on everything. So we built our own memory management modules. We paid attention to disk I/O. We were sensitive about how much memory you would use on anything. So it wasn't like you could just go grab memory, because if you grabbed enough, then the other part of the code would start breaking apart on you. So we were very sensitive about who was using what memory at what time. So.
Right. And even though you were using PCs, at first this was not Windows. You weren't, we all use Microsoft Windows, but this wasn't on Windows. So where did you start?
Yeah, so that the whole DOS world, just to give you an idea, the first code that we converted over it was a NATO code called NRMM, and actually I think they still use it today. To get that running on the PC, we needed way more memory than 640K, right? Even though Bill Gates said 640 is all we need.
Right.
But we found some examples, assembly code, about how what they called back then VDIS worked. So that was the virtual disk where you could take and extend your 640 and use hard disk space as a way to fake it into memory. So we found that assembly code, and we reworked a lot of it, and we got it to where the Fortran code could actually allocate memory into that space. So that was the first attempt of moving some of these bigger codes running on PCs that were only 640K. But I think looking back, just the getting simple stuff that we would consider today running on those laptops were just a major pain in the tail. So
right. So tell me this: when you were doing all that work, the culture of your team was different than what we have today. So kind of explain that and tell about what the culture of your working environment was.
Yeah, so the like I said earlier, the core group was, so you had TC, Ben, and myself, and we were all three, we're as different as you can get, okay? So TC was high intensity. I mean, we were working, 1,000 hours of overtime a year, but it was natural for TC to do that, okay? Ben was a perfectionist. He liked to polish and shine things. And, I thought my strength was bringing new ideas and new techniques from the computer science. I was the only computer scientist in there, so I brought that whole dimension into this area. Efficient data structures, things like that. How do you deal with buffering and those? So those areas were really not something that TC and Ben were exposed to in their academic career, and I was able to kind of bring that piece. So I thought the three of us made a really good team, and we were making tremendous progress, getting a lot of press. Then we, like you said, 5 years later, we added you to the team, and then over a period of time, it kept growing and growing, and we split it off. To me, the remarkable thing looking back is that we were able to do to advance this technology over time. We went from MS-DOS. We kind of, in essence, skipped Windows. We wanted to get back to Unix. So there was a company out of California called SCO Unix. I think that was like in 1998. They came out with the first Unix that would run on the PCs.
Right.
So we immediately switched over to that environment. TC got into X Windows. We got all of our graphics running into X Windows. But Unix gave us a lot more capabilities than we were ever going to get out of DOS. So we got the system built in Unix. And then over a period of time, it really matured. I mean, we really knocked out. One of the things I wish we would have done is probably look at, documenting more about the unique things that we put together. I look back, the whole tiling of geospatial data, I think we were pioneers in that area. We probably could have got patents and things that we really didn't pay attention to. Back then, Esri was the state of the art in the commercial world, and if you wanted to look at adjacent maps. You had to load one, and then you unloaded it and loaded the one next to it.
Right.
That was just so inefficient. We really wanted to look at how we can work across the seams, because the data was given to us in what back then we called quad sheets, and we wanted the computer to seam it up, not humans to seam it up. And I was taking a graduate class in spatial data structures, and we came up, as the professor was lecturing, he talked about these things called quad trees.
Mm-hmm.
And I think I went home and I had a hard time sleeping that night, so I came back and we all three got on the board and we looked at how we could use the quad trees. And really it was a early approach to pyramiding that we see now in the spatial world. So we built that whole quad tree pyramiding scheme into our system, and it really allowed us to scale to huge data sets, way beyond what other systems were able to. I mean, I can remember back in the very early 90s, maybe 90, 91, that we were able to put, multiple countries together at 30-meter resolutions on those systems, which was really amazing. So that system got so much traction, it ended up being adopted by the Army.
Right.
And the Army took it. We got MITRE involved. MITRE helped us kind of put the finishing touches on it.
Right.
And the remarkable thing looking back is that it was the flagship mapping product for the intel system and the operation system during Desert Shield, Desert Storm.
Right.
So all the maps that the soldiers were using that were going to the tanks and things like that was built based on the three guys that we put, the effort there.
Yeah, I think it was actually every command and control system in the Army for that period of time was based on the code that you guys wrote.
Yeah.
Until, the late 90s when Esri became the mapping thing.
Well, when Esri caught up.
Right.
We were so far ahead. And actually looking back, all this stuff was going on in the late 80s, and some of I go back to one of our earlier programs called ALBI, Airland Battlefield Environment Program, which was an idea of looking at these multi-domain environments,
right?
How we get air and sea and stuff like that to play together. Well, we put the ALBI system together. We partnered with the GRL guys, or back then they were called ETL, and we put this remarkable system together. And that thing was running into like 88, 89 to do tactical decision aids. I would argue that it would be pretty cool even today.
Right. Oh yeah.
So it was way advanced in terms of its time and stuff. So those are some really proud moments that I have of our work. But looking back, we never documented, we never wrote about it. Our job was, we were so busy writing the code, making the impact, that we really didn't take care of ourselves. And I wish we would have done a better job of writing about it, communicating the unique things that were done here at Waterways back then.
Right. So when I came on, this work, a lot of it had been done, and it was still ongoing. It was kind of towards the end of ALBI,
yeah.
Right? And that was when you got your own project, Ops. And one of the first things we did, for at least that I remember, was we went out and demoed it.
Right.
Right. So, and we took an interesting tact to demo it. It was much different than what we do today when we go demo. And it's like some of my most painful memories that I have. So kind of explain what you and Philip did to take these systems out and demo them.
Okay, so just a little quick thing on Ops. So the counter mobility, back then we had mobility program here at West, and then we had the counter mobility program. The counter mobility program was inside of the environmental lab. The mobility program was inside of the geotechnical lab. So the West leadership decided to bring those two together. So they moved the counter mobility over to and partnered with mobility, and we were able to take advantage of a lot of the stuff that we built in ALBI and TIM and things like that, and really kind of advance that whole counter mobility space. But the problem that we were running into, the Army was going through this whole transition to computers, putting networks on battlefields and stuff like that. So the question was, how do we play in that space? So doing it here, sitting in our offices, shipping disk out to to Fort Hood, Texas, or the National Training Center, or wherever these guys were doing their work, it didn't allow us to get involved. Getting involved from a distance wasn't going to work. So there was a guy that I worked with on the counter mobility program, Philip Dwarn, and Philip argued that we need to be in there with them. All right. So we took some of our research money and bought a Suburban truck. All right. It was just a surplus truck that the government had. So it was just an old white Suburban truck. So we took it and got it painted at the reserves, the Army reserves, and it looked just like a military truck at that point. And we got the tires put on it. We got the night lights put on it. We took the whole back end of the truck out, and we took it over to back then. We had a group called Instrumentation, and they put the racks back there. And we were able to run or put our Unix machines. I think we were running probably HP machines back then.
Yep.
So we were able to rack mount the HP systems. We had a plotter. We had really amazing plotting technology back then. We could do plotting on clear acetate. We could fill up the walls with numerical, modeling results and stuff like that. So from the outside, you would see this old truck, but if you opened the front doors, it was nice and plush. It had the big captain chairs in it and stuff like that. It had the nice stereo system and all that. But you turned around and it was just nothing but computers in the back. But what that enabled us to do is that we would get invites to go to these battlefield testing environments. So we would take this truck and drive it right up in with the tents and stuff that were out on like at Fort Hood or whatever, and we would wire into their network, and we would run analysis for the teams and stuff, and we were providing them capabilities that they were having to manually do, and at some point we looked like a Chick-fil-A or something. Like they would line up. We would have people in line waiting for our products, and we were working around the clock, running the analysis, getting the plots done and getting them out. But I think what we were able to do is give the Army that aha moment, saying this stuff, letting the computers help us make decisions is a big plus for us.
Sure.
And so back then, General Sullivan was the head of the Army. He started this whole digitization effort, and so going all the way back to the 80s, getting the TIM, the Desert Shield, Desert Storm, and then working on moving the Army into this digital world, it all kind of built up. And so the trick is that what we concluded is that computers can be such an advantage for our military because they can give us information that helps us, perform well.
Right. And so for the record, when you went out on these exercises, did you work the day shift or the night shift?
Oh yeah. So that's it. I can remember flying in one night to Fort Hood, Texas, and I came from Washington. So back then, believe it or not, if you went to Washington, you had to wear a suit.
Right.
Okay. So I flew in. I had my suit on, my tie, my nice shoes, and they picked me up at the airport in a Humvee, and I had shipped my duffel bag out there, and my duffel bag was in the Jeep. So I had to change clothes, and they dropped me off at my tent, and it was raining like unbelievable. The tent did not have a floor in it. Okay, there was actually a river or a creek or whatever running through the tent, and I was trying not to get muddy and nasty.
Right.
And I got dressed, but a couple things that happened ends up a lot of stuff's co-ed out there. I didn't realize that. So I'm in my sleeping bag, and I didn't know who was going to be in the tent with me.
Right.
So I was trying to get some sleep because I had an early morning shift, and a bunch of ladies show up and they start getting in their cots.
Right.
I'm going, am I in the ladies' cot or what? But ends up that, it was just a mixture out there. So,
Right.
But, I was running a lot of times, well, I took the day shifts, and since you went with me, I gave you the night shifts. And then ends up that one of your night shift guys was on television in 96 when I was in College Station working on my PhD. And I recognized the guy. He was one of those don't tell guys.
Yes, he was. In the closet, so to speak.
So I remember calling you and saying, what went on in that tent? So,
yes.
But I think that looking back, the key thing for us moving forward, I don't want to get too far advanced here, but I mean, in front of you, but the trick is that we took our scientists and put them right in at the tip of the spear. Mm-hmm. And we got to see the problems. We got to experience the problems.
Yep.
And you cannot be innovative if you don't have that, if you don't get to do that.
Right.
The innovation occurs I really think when we put our scientists in those situations and they see it, they feel it, and they actually start owning it.
Right.
And then they can come back and use their science and their engineering skills to kind of solve these problems.
Right.
It's really hard for us to do the innovation sitting in our offices.
Right. Well, I think we found out that our customers, the Army guys we were working with, had a hard time articulating the problems. They had problems. They knew they did.
Right.
But it was hard to articulate, right? So when we were there, we could see it for ourselves.
Yeah. The standard way is that the guys in the field, they would take and they would say, hey, here are our problems. And that would go up to the high levels in the Army, and then that would jump over from the more of the tactical operations side over to the research side, and then they would set the research programs up, to address this. But that to me, that's an innovation killer. I think the short circuit is, and this is what I call the true power of ERDIC, that industry doesn't have the ability to do this. We can touch the users. Right. Industry, they don't get that opportunity. They have to sit back at their nice facilities wherever and speculate what the problems are. Mm-hmm. When we can take advantage of our being in the Army, we're all Army employees, we can go to the problems. We can experience the problems. Right. And I think if we can get our scientists out there, and especially our technology guys, let them have the aha moments and come back and build. I don't think you can have that aha moment sitting 3,000 miles away from the problems and in your office on a whiteboard speculating how you can solve these things.
Right. Okay. So as we got later in the 90s, you made a transition.
Yeah.
So let's talk about how that went.
Well, so I was the lone computer scientist in the geotechnical lab, and it wasn't friendly for the promotion thing. I really struggled with promotions because their business is civil engineering. So I kind of, in a roundabout way, as you progress in your career, you have to kind of look out for yourself a little bit. You can, that was my first family over there. I have some really good friends, and we did some really creative things. But I realized that there was only so much I could do. So I was kind of in a flux myself. I got accepted to go to long-term training. I had a tremendous offer to work with the professor at Texas A&M that was really a guru in AI. So I went out there and I did my 1 year of coursework, but I got back then they were not called 219 or fifth proposals. Back then they were called ILLARD proposals. So Dr. Wayland gave me 3 years of ILLARD money that allowed me just to focus entirely on my research. So I spent a lot of time in hotel rooms, just on campus. I really think being in that environment, working with other graduate students, is a nice learning process for you. That's the thing that concerns me about the modern day graduate school is that you do it online and you don't get that connection. You don't get to hang out with graduate students. You don't get to share ideas. You don't get to understand how people look at things differently. I think you miss out on that. So I used my Iller money. I did a lot of TDY camp. We spent a lot of time in hotel rooms. The 3 years that I was working on my research. So when I came back to when I was getting close to finishing, the whole geotechnical lab in the mobility group, the whole leadership had changed. They all retired at one time. And this is a danger of everybody being so close in age and leadership. They all walk out the door within 1 year, and then everybody's kind of looking at each other and going, what do we do, right? So that's a concern I have here in ITL, is that we really need to mentor and bring up the next generation leadership and not just walk out the door. So at that point, I'm going, all right, I'm in this flux. I've kind of disengaged from my previous research. You took over ops.
Right.
You and Philip were jamming on it. So I didn't have any connections there. And it was just a good time for me to hit the reset button. And I tell people that a lot of times, is that it's hard to come into this environment in research, especially in computer science or any kind of technology, and think that you're going to stay in one lane for your entire career. I think you have to be very agile. All my research, actually my senior project in undergrad, my master's degree, and my PhD were all in AI. But AI wasn't a very popular thing back then. So what I ended up doing was using my AI to help in areas that were popular. Like our whole mapping thing, how to do decision support things. So even though I wasn't getting to say, hey, we're doing cool AI stuff, I was still able to use the skills and stuff from my school. But I was just at a good point. I came over and met with Dr. Rada. He was the first director of ITL. Back then, they didn't really like people moving around. It was a big deal for the lab directors to shift personnel. So I had to get Dr. Marcuson and Dr. Rada to agree to the shift. And I think Marcuson realized that me being a computer scientist over in geotech was not going to be a good career move for me. ITL, you would think we had a lot of computer scientists back then, but really we didn't. I would say it was maybe less than 15 when I first started in ITL. So that was one thing. Dr. Rada had kind of built ITL as a group of different components that he pulled together. In essence, they had a lot of computer-aided engineering. That was his focus. That was Dr. Rada's. His research area was in CAD. So I would argue that the foundation of ITL was started more in using computers to do engineering. But Rada was very nice. He let me come in. He didn't bother me or anything in terms of I got my research done. I graduated in May of 2000, and in October of 2000. So I had a little window there of, all right, I had my PhD. I was trying to set up me some research programs. In October of 2000, ERDIC created this thing called technical directors. All right, that was the beginning of ERDIC in October of 2000. So Dr. Rada had already retired, and Tim Abels was running ITO at that point. And so I remember being in my office, Tim coming down, he said, hey, Cary, ERDIC has starting this new thing called technical directors. And there's a meeting coming up like October 15th. It was sometimes in the middle of October. And I'm going to make you ITL's first technical director. Now, it was an acting position, but I got to, become the first TD at that point. So I went to my first meeting, and it was at Tech, all right, or GRL. We were in one of the conference rooms right there as you come into GRL, you take a right, and the conference rooms are on the left. So we were in one of those rooms, and I was, for some reason, I was running a little bit late. I think I flew up that morning. The meeting was in the afternoon or something. So I walk in, and everybody's already in there. And, of course, I'm like 34 years old, okay? And they look at me like, are you in the wrong room here? So I'm going, nope. I said, no, I'm the new technical director for ITL. And most labs had either 2 or 3 back then, so that I was the onesie. ITL only had 1.
Right.
So in that room where, I mean, you had, like, Dr. Holland was a TD. Dr. Mosier was a TD. You had John Cullinane. Dr. Cullinane was a TD. You had, like, Bill Garan was TD of Searle. Alan Moore. These are. So this was the beginning of the technical directors.
Right.
October the 15th or whatever, somewhere in that time period of 2000 is when it all started.
Right.
And I was coming from the military side. So in GSL, they'd already merged. The 2 technical directors were Paul Malarker and Reed Mosier. So Paul was kind of more of the GL TD, and Reed was more of the SL TD.
Right.
So I knew a lot about Paul's space and things like that, but I quickly realized that I have to give that area up. That wasn't my area anymore. That was Paul's area. And I was looking for partners and stuff like that. So my first partner in terms of being a TD was Dr. Holland. So Dr. Holland was TD in CHL. And we kind of partnered on some projects, and that was my first experience working with him. Dr. Holland, as everybody knows, is very intense. He's a get-it-done type of guy. So we worked together from October 2000 until Dr. Holland was actually hired as the lab director, I think in 2003. And then at that point, he hired me. I became a real TD at that point. So that was either 2002 or 2003, and then he got this other guy from CHL that he worked with. His name is Dave Richards, and I look back and I kind of laugh. I think Dr. Holland had this experiment going on because he couldn't have chose a guy that was complete opposite of me.
That is true.
If you enumerated 80 categories of human behavior. And you classified me on one side, Dave would be on the complete opposite side. Dave and I mean, just from the physical standpoint, he's like 6'3", big guy.
Right.
I'm 5'6", little guy. He went to University of Texas, which is a liberal, and Maryland, which is kind of a hippie school. I went to conservative Mississippi State and Texas A&M.
Right.
I mean, everything you can bring up. Even his politics is wrong. So, but we're so different. But I think Dr. Holland knew that mixing people with different perspectives generated really cool things. And so Dave and I started working together 2000, 2003. I went to lunch. I spent more time with him than I did my wife. Okay.
Right.
And so, we kind of moved on, and that was kind of the beginning of the ITO-TD office. We started in the offices that in the hallway. Dr. Holland, of course, had the office that I'm in now, and Deborah Dent was the deputy back then, and so Dave and I were in the offices that Devin and Marty are in.
Right.
And so we had a very small office. Dr. Holland didn't let us have big things. We had Bobby Edwards was our administrator, and that was it. We didn't even have ATDs back then.
Right.
I think probably 2 years later we started ATDs, and Wayne Jones and Denise Martin were our first 2 ATDs.
Right.
And I had Dolores count. Probably in the order of 25 ATDs have processed.
Really?
Yeah.
25?
Yeah, including acting.
Right.
So I think the ATDs are, to me, a good way to build leadership for the organization. So we kind of use that as the way of getting people out of their projects and having them kind of step out or step up a little bit, seeing the bigger picture, and kind of learning, building relationships, and using that to move forward.
Right. So that means you've been a TD for
20 years.
Almost 20 years.
No, 20 years.
20 years.
Right.
So probably the longest serving TD.
I'm the only TD left from the original group.
Right. Right. Huh, that's interesting. So so when you came into TD, you're doing TD, you and Dave, and I know this is probably not something you necessarily would normally talk about, but I think you should talk about it. At some point, you got a promotion when you're in your TD slot that most people probably don't know about or even understand what that process is.
Yeah.
Could you explain that?
All right, so so Dr. Holland didn't stay here very long.
Right.
So, he's a fast mover. So I think he came in like in 2000, 2003, but he was out the door by 2006. He became the deputy for ERDIC under
Right.
Dr. Houston at that point. So the lab director position became open.
Mm-hmm.
So I'm going, I might try for this.
Right.
So we had a lot of people apply for that position back then. So I'm guessing that I heard it was over 10.
Mm-hmm.
So it was, of course, when I went to headquarters and interviewed, when I was in the chief's office, there were 3 of us in there. It was Reed, Deborah, and myself,
Mm-hmm.
and we went through the interview process. Of course, Reed got the position, which was fine. I mean, Reed did a really good job. So I came out of that, and I was, Dr. Holland said, keep your head up. There's other opportunities. So they were creating these things called STs. Those were we still have them today. But there was another thing that Reed was coming into this. Reed was this thing called DB6. And back then they were all managed at the Army level. So the Army basically said how many DB6s that we want and what areas do we want them in. So there was so Reed's position was freed up with him becoming lab director. Mm-hmm. And there was an idea that we wanted, Dr. Holland had worked with the Army leadership, that we wanted a computing DB6. And so they put that position out there. I put I can remember putting the package together. They were huge. Okay, mm-hmm. They were like a DB5 package times 3 or something. I mean,
right.
Because you're at the Army level, they're out looking at everything that you've done in your life, what innovations, how many papers, stuff like that. So I put that together, and in 2008, I got my DB6, which was really a remarkable thing. So
right.
That I remember getting that, and Dr. Morris was the he was the deputy.
Mm-hmm.
He had just finished being the deputy. That's when Holland, he left the position open, and then Holland left ITL to take Dr. Morris's position. So I remember going out to dinner one night with Dr. Morrison, and he said, anytime you get a big step in your life, you need to reward yourself. So I went and bought me a new car. So that was my reward for being the...
And what kind of car was that?
I got a Nissan Z. So.
A Nissan Z.
Yeah.
And what do you drive today?
A Nissan
Z. Good deal. So you got your DB6, and over the past 6 or 7 years, our work has transitioned a lot, right? So when I came over here in 2003, we were doing pretty heavy software development, right? And we were building tools and doing some web service stuff, and that was all interesting. But then we started a transition, and you kind of led that transition, and we're kind of it's starting to ramp up pretty big now. So kind of talk about how that happened.
Okay, so when ITL was first started back in the mid 80s, we had a division that was led by Wendell Ingram that was primarily developing software systems for the Corps. Mm-hmm. And we've kept it. Actually, it's kind of it's the precursor to what Ken Patrick has right now. But one thing that I kind of looked at is that building big software systems is difficult for a lab to do that. You really have to be set up to do it today. Like, you got to have really good testing environments. You got to have really good development environments, and the developers have to have all these software engineering skills, and they just don't. That just doesn't happen overnight. You have to build those capabilities. Mm-hmm. So it was probably a decent thing back then because there wasn't a lot of this formalities that they have today in software. So you could be kind of ad hoc back then in Windows days. And we do have some legacy that we've kind of moved in doing, like Promise and P2 and FUDSMIS and those systems. But personally, I just think that that's not in our wheelhouse anymore, writing big software systems. We're just not set up to be as efficient as industry could do it. Right. So there are companies out there that are really good at this. They have the environment set up. They have the team set up. It's too hard for us to work in that environment. So we started ERS, the thoughts of ERS, in 2012, and we were doing these piloting efforts with the Navy and such. And I was sitting there watching, and I'm going, the biggest challenge that the Army has, or the DoD has, is dealing with all their data. So can we get in front of this and start this whole like a data initiative? So there were a couple of innovation days that when at this point Dr. Holland was director of Verdict, so we had these innovation days, and we kept pitching. We want to do data analytics, data science, and things like that. The pushback was pretty bad in the beginning, because what you'll get from the old schoolers is, we've been doing data for years out here. We've got this. But what they didn't understand is that data and data science has incurred a revolution, and that's through the integration with AI. And it's data science and data analytics is not the what we used to have with SAS and MATLAB and things. It's like 10x that now. And we could see it early through ERS. And so we started preparing for it. We put in some proposals. We worked with Dr. Holland to get some 219 investments made in this space. We focused on some recruiting, so we got some university professors to join us. And then the neat thing about it is, if you can get some high-level knowledge in this space, then you can bring in your scientists or engineers that have good computing skills, good math skills, and these mentors just can take them into the space, and you can actually grow the team. So we started out with the university hires that we did, and last count it's kind of a rough number, but we're up into the upper 20s now. And I really believe that we're just now touching this space. Everybody all of our clients, the PEOs, the PMs, the USACE, even people in cyber, everybody's generating zoodles of data. They don't know what to do with it. And we've been collecting data for years, and it's just sitting there rotting. But there's so much insights in that data, and I think a really good business for us is to build and be the leader in that space, because we do have a niche, and the niche is, if we have the data science team, then the two other components to the puzzle would be good computing, which we have, and then the other piece is really good software techniques, and we're getting that free from industry. So the combination of the workforce, the computing, and the industry tools really sets us aside. And so we really focused on getting the workforce built and running problems. Now the difference is, I get this question a little bit, what's the difference between data science and computer science? Well, a lot of times we use our computer scientists to write software. So we're not really doing computer science. We're using our computer science skills to write efficient software. But and these software efforts, even the simplest software efforts, is going to take you a year. All right, software is hard. Okay, but data science is different. It sprints, because it's very iterative with the end user. So you go, you get their data, you get it cleaned up, you run the analysis, you're batting it back and forth between the decision makers, and you're building relationships, and you get really close to these decision makers, the people that are at the tip of the spear, and we're helping them make decisions, and you're seeing the decisions, and it's really motivating for the team to see that almost immediate impact. So the environment is really fun. And it's not like you're writing software and you send it off somewhere and you speculate about how you're impacting, how you're impacting your community. That's the thing that always gets me, is that the impact motivates me. So if I can see me making a difference, it just charges my batteries and I want to run harder. That's the beauty of data science. It's you're actually seeing the differences that you're making right as you're making all this data work for you. So I just think it has tremendous growth potential for ITL and for the Arctic. I don't really see this being an ITL thing. If the limitation of data science right now is there's a good bit of IT in it. So to be a really good data science guy, you have to be comfortable doing installs, getting things to work. You're downloading software so it's kind of an obstacle for someone maybe coming from chemistry or biology or whatever to come into this space to deal with the IT component of it. But I think in the next 5 years, you'll see that IT component kind of fade away. We're seeing some work in industry right now, building these environments that are very robust, that kind of abstract us from the IT space. Like Databricks is an example. I think that's you bring Databricks in and you just start jamming on it. You don't see the IT anymore. I think once that happens, you get the IT to fade away, then it's going to open the door to biologists doing this, to chemistry guys doing this, and it's just not going to be a computer science thing or a math thing anymore. Right.
So I want to go back, something we didn't talk about that happened earlier. There was a big program in D.C. that you became aware of and were pulled into, called TIS.
Yeah. So
tell us that story.
All right. So that's a really good story. So there is a little history to that. So I think the day was Dr. Holland was deputy of ERDIC, and we had a lady running. Back then, this was pre-ACID, so we had this thing called CIS, Corps of Engineers Information System. They were like the predecessor to ACID. Okay?
Right.
And then we had 2 data centers, one here in Vicksburg, one in Portland for the Corps. And so there was some genius in Washington that said, hey, you got too much IT in the districts. You need to get the IT and consolidate it and try to give as much of it to industry as possible. So back then it was called this A76 thing. All right, so keep in mind in 2000, half of ITL was operational. So we had 2 divisions. One was this computer engineering group along with the software development group that Wendell had. We kind of merged that into one division. Then we had another division that Alice Duke ran, which was the operations division for ERDIC, it was for ERDIC then. Okay, they did all the security, the networking for the entire 4 campuses. So the A76, what happened was they took that whole division from us. So in 2006, we lost half of ITL. I can remember Dr. Holland saying, it doesn't make any sense having a lab with one division. There was even some notion of making us a center under the colonel. So I can remember Dave and Deborah, we were sitting in her office, and we said, we got to fix this. So what was really remarkable was, like 3 days after we had that meeting with Dr. Holland, Dr. Horner, who was a TD in GSL at this time, called me and said, hey, I got this project that I'm working with, that GSL is involved in Washington, called the Transportation Information System. And they're having huge problems right now. Will you come up with me to DC and tell them about ITL? So Dr. Horner and I went up there, and I briefed them on ITL capabilities. And I didn't even get to the last slide, and they basically said, you're hired. What we want you to do is we're firing our contractor, and we're going to turn all this over to you. Now keep in mind, this project was like $150 million.
Wow.
Okay, so this was serious. This was the system that the Army used to move supplies from their warehouse in theater to the individual troops. This was a critical system, but it was having all kinds of security issues. I want to say, you might have to help me on this. It was used, the database system for it was called Sybase.
Right.
All right. Sybase was out of business. Okay.
Yes, they were.
So we had a database that was moving all of our resources on the battlefield, and the company was out of business. The security people were flying around like buzzards, going, "You got to get this out. You got to get this out." They had all kinds of security issues. Their software systems was. I mean, this thing was a wreck. All right.
Right.
So on the way home, I went up there by myself with Dr. Horner. I flew back by myself. So I called Deborah and Dave, and we were jamming. We were talking on the phone, and I said, "This is going to be a lot of work, but the Army needs us. There's no company that's going to come in and fix this. Only ITO can fix this." Okay. So I said, "Deborah, are you willing to?" Because Deborah was acting director at that point, and she said, "Yes, let's help them." All right. Now, what happened was there was a bunch of people in ITL that didn't make the ACID transition, and they were hanging there. They didn't know what they were going to do. Okay. So we basically got this project, and we took all those people that were in question about their background, because they were more operational.
Right.
Well, there was a huge operational component to this, and we moved them over, and they became the TIS team. That was the beginning of the TIS team, and we rolled our sleeves up on that thing, and we worked and worked and worked, and it was a shining star when we finished. So that TIS team, I mean, you got people like Chrissa Rowland. She was a security person under Alex Duke. She was actually, I think back then she was a contractor. So we hired Chrissa to come in and be our security lead. Mark Lieber was the kind of the ERDIC lead for that. And Mark called me on the phone. He said, this lady right here is really good at security. You need to grab her. And so we got Chrissa, we got Ronnie Hitchpeth, and a bunch of other guys in his group, and they became the foundation to TIS. And we spent we probably spent 7 years in that program, millions and millions of dollars running through it. But we made it through the Iraq War, and we made it through the Afghanistan War, and without any problems. So we took a system that was completely upside down, and we made it through 2 wars with no complaints. So that's, again, an example of us doing really good work, but doing not so good a job of communicating what we did.
Right.
So I think, leaving, that's, we always forget that. We should never forget that. You have to brag on yourself a little bit. A lot of times we get so caught up in the science, and we want to do the science, but hey, you got to communicate this stuff. Otherwise, if you don't write it down or you don't communicate it, it never happened.
Right. It's like it didn't happen.
Yeah.
Right. And most of the people in this building have probably never heard of TIS.
Yeah. So it's still running today. We did, for the Afghanistan thing, which was a little different, we had to, we didn't move stuff, we didn't move the materials around on the ground. So TIS was built, it was kind of like the FedEx system for the Army, all right? It was built for moving things with trucks and stuff. But in Afghanistan, you really didn't want to drive around on their roads because it was pretty dangerous. So everything was moved with helicopters. So we had to go back, and we brought a company in out of Dallas that worked for Walmart that helped us get the helicopter components put into this thing. The other thing that I thought was remarkable is that we realized our limitations in ITO, that we didn't have the team to do something this massive. So Ronnie and that group, we made the partnership with Microsoft, and we got Microsoft to come in and help us transition from Sybase to the Microsoft SQL Server. Right. So keep in mind there were a zillion embedded functions in this database. So Sybase, you you wrote functions, but you embedded them in the database, and they were in their Sybase language. So the migration was massive, and we paid a lot of money for it, but we got it taken care of. So we got the database taken care of, and we got the security taken care of. I think the thing looking back that we really missed out on is at the very end we got it switched over to a web application. But at that point was when we kind of we turned that back over to PEO EIS at that point, and I'm not sure if that ever made it across the finish line. But we did get we had a company help us migrate it was an installed client back then. It was a desktop client, and we had the whole interface re-engineered to the web. I wish we would have stayed a little longer and got that across the finish line. I'm not sure if it made it.
Right. Gotcha. Okay. So you're at the end now, right?
Right. Well, I'm at another step in my life.
Another step at your life.
Right.
So what are you going to do now that you have a lot of extra time on your hands?
Yeah. So I'm working on a novel. I've been working on it. So the last year I spent working at the underneath the CIO's office in DC. So I would go up 1 week out of the month and spend my time up there, but helping them with this whole data initiative in USACE.
Right.
So we have this big Data 25 thing going on. So there was a lot of nights you're just sitting around in the hotel room. And I had started working on this idea about 2 years ago. But it's just a tremendous amount of work. Oh my gosh, it's a lot of work. And my writing skills were set up more for technical writing, and creative writing is totally different. All right. All the years of the editors and stuff saying take the fluffy puffy stuff out and just state the facts.
Right.
All right. So over 30 years of training, you almost write like bullets in a sense.
Right.
You're just getting the facts in this thing. So now I have my editor working with me, and it's like he gives me books to read about how to do creative writing, and so I've kind of retrained myself to be a little more descriptive in my writing.
Right.
And so my book will have like 18 chapters in it, and I'm on chapter 16 right now in terms of the first edit pass.
Right.
The first pass, the editors look at the dialogue, the story, the continuity, and things like that. The second pass, the edit, is what I would consider more of a traditional edit, dealing with making the language more exciting, taking a lot of repetitive stuff out, dealing with grammar and things like that. So I'm almost finished with the first pass, which is really the hard pass.
Right.
So.
Right. So what was the hardest part of that book to write?
Oh. All of it.
No. You don't have to give us any details. I just want to know which part.
But there's a lot of the relationships that you write about, and the whole time I'm going, my wife and my kids might read this. I'm having to deal with that. But
so you're saying the scenes are more on the intimate side?
Yeah, the intimate. Yeah, that's not easy. But the editors, that was really the knock when I first took my book. I've written this thing like 3 times. You take it to the publishers, and they read it and they give you comments. Well, they didn't think I had enough attention to build characters.
Right.
They wanted me to spend more time on character development and stuff. And what that means is that you got to have dialogue, internal dialogue. You got to have relationships going on and all this. So it's more than just the original. The book is kind of on AI and the future of AI. So it has to be more than just the technical aspects. You got to have all these stories and these threads going on.
Right.
And that part was a little uncomfortable to write.
Yeah. I read one of your first drafts.
Yeah.
And it was very technical manual feeling, right?
Yeah. So they got on to me about that. So the editor that I have he's really good. He's very patient with me, and he's helped me a lot in terms of my writing skills and stuff. I think if I were to write another one, it would go by much faster because I'm more prepared now. But I'm not sure. I might be one and done here, so I have to look at it. But I think for me in the future, I'm going to go spend some time working in industry. My brother's going to get me to help him a little bit, and my focus is primarily going to be on AI. But looking at AI, I think that's kind of the next thing for ERDIC as well. So we moved into this data science arena, but AI is staring us right in the face.
Right.
And we've got to figure out how we organize and move in that space, because how we let machines help us do these very complex problems in the future is going to be important. And ITO needs to we need to go ahead and start forming our thoughts and how to move in that area. I've talked to Dr. Horner about maybe having an ATD position put in just to focus on on AI. And I think going and working with my next job, they're very interested in how AI can help them in terms of better improving their products as well.
Right. Okay, so one question for you. What is the maximum number of cars you've owned at one time?
So when in 2016, I moved back to my hometown, and I reconnected to some of my high school buddies, and they're all into antiques and things like that. So a lot of people don't realize this, but when I was in high school, I worked as a mechanic at a motorcycle shop. So I love working on engines and stuff like that. So I reconnected with my high school friends, and we do cars. Sylvia and I, when we moved to this new house, we constructed it. The funny story is that our garage is almost as big as our house. So we really kind of downgraded. We had our house that the kids grew up in was too big for us, so we tried to go small. But I went really big on the garage. So I have my cars and stuff in the garage, but they're also in the driveway as well. So I don't think I can have any more cars. Otherwise, I'm going to have to go find another place to sleep. But right now we have 6 cars.
6 cars.
Yeah.
For 3 people.
Yeah, for 3 people. So I have, but to be honest with you, if you know what cars to buy, they're great investments. So but the trick is you got to know which ones.
Now, you flipped a lot of cars.
Yeah, I flipped. I've probably, since I've moved back to my hometown, maybe 6 cars. They take a long time to do it by yourself.
Right.
So it's kind of a hobby, but I've kind of put the whole car thing on the back burner until I get the book. So I'm really sprinting hard on my book. So I'm hoping to come back maybe in March and April timeframe, and I could do like a book signing here in ITL and get you guys to. I might sell 10, and it might be the 10 from ITL. So I'm hoping that that's one of those things. If you've ever tried it, it's really, really hard to do something of that order of magnitude. Actually, it's probably as close in terms of complexity as like my dissertation work, writing that dissertation and getting that thing going. So, but there are probably people that are really good at it. They can write those things very fast. I've had the story, so the story's been there, and I think it's a really good story. It's just making it where, as my editor would say, people want to turn the page. Right. You have to. If they don't want to turn the page, they're going to shut the book. So he asked me all the time, "When do people want to turn the page?" And the other thing that he gets on to me about a lot is I have a tendency of telling things rather than showing things. And so I would say, like an example would be, we went out to the golf course and played a round of golf. That would be telling people you play golf. But a showing example would be, we were on hole 3, and I hit my longest drive, 350 yards. I don't really tell them I'm playing golf. I bring the golf into the story. Right. And that's been the big change for me, is not getting out of that telling mode and more into the showing mode. And actually I've used that in my data science work. So we have these pilots going on in USACE, and they came from that idea that rather than us walking around in headquarters or in these PEO offices saying data analytics, data science is the next great thing, let me show you my PowerPoints, we've kind of moved that to a side, and we're going, hey, let us show you some of the insights we've generated, and let them have that aha moment, and let them we're showing them the power of data analytics, not just walking around with a bunch of PowerPoints.
Right.
So that seems simple, but it's very, very powerful if you think about it.
So you talked about your work at USACE, and you've gone up there every month for a week or so, at least for the past year, and that's really your last thing as you walk out the door. So what do you think the impact of that is? What do you think the future is for that?
So USACE, so I started my whole time in GSL or GL was spent on the military side, and what I've learned is that if you could show a 1.2x capability for the military, they will take it and run with it.
Right.
They're just starving for advancements.
Right.
Not so much on USACE. USACE is a little more cautious about how they move.
Mm-hmm.
All right. So what I've learned is that don't expect big changes fast on that side.
Mm-hmm.
It's a marathon, not a sprint with USACE. So pace yourself, work your connections. And one of the things that I talked to Dr. Horner about that I think is important for IT in the future is that we need to focus on relationships. We need a team of what I call our mid-layer managers, or rainmakers, building relationships with the community. And that's what I've done. That's what I spent my time with at headquarters, is focusing on getting to know people up there,
right.
Getting to know the circles and the connecting the dots. And so I went up there yesterday for my last meeting, and I said bye to everybody and things like that. So we need more of that, and I think Dr. Horner is going to kind of start pushing that. So we got like Lacey is working at Jake. I know Krista did a stint at Jake. Devin did some work at ASALT, so he has those connections, and I did my USACE thing. We need more of those. Relationships allow us to influence, and that's the key for us, is influencing how things move, so we understand where things are going to move, and we can connect the technology to where they're going. If we don't do that, then we're basically in a dark room guessing where things are going. Right. So we need those people out embedded in these worlds that we're interested in to help direct where we move our technology and things. So I think in terms of Data 25, the USACE will be kind of slow to adapt. Mm-hmm. And so we got a new CIO in, and he's getting his feet underneath them. He's not a USACE guy. He's coming from outside. Mm-hmm. So this USACE thing's kind of foreign to him, and he's trying to understand it. So there's going to be some time for him to get some traction and get his thoughts together about how to move forward. So there's some things that we have in the oven in terms of where we want to move, and maybe some new hires that we want to bring in that space. But in terms of moving out, I think we go back to, we show them, we don't tell them. All right. So we have relationships that we built in 3 business lines. We have the 3 pilots that we were funded by the CIO last year. The 3 business lines would be hydropower, dredging, and then the military construction. Right. And the ITL team that's worked on this has spent a lot of time building relationships in these business lines. Right. And we should just drive and press forward in these business lines, and we show the organization the power of data analytics, and we don't catch ourselves walking around headquarters or the Pentagon with PowerPoints with this, what I call Pentagon speak, saying that this stuff is good. We actually show them it's good, and we bring it right to their world, right to their problems, and they have the aha moment. And when they have that, then you have that relationship, and then you can start working your influence on it. Right. So I think I think we have to be patient. Dr. Pittman started all this with the EGM that happened in 2018, and he worked with the chief. We've got a lot of senior executive support at headquarters in this space. So we have the Data Governance Board, which is chaired by the DCG. So he's a huge fan of what we're doing. We got a lot of senior executives, like I said, involved. Marty Kitchell's done a remarkable job communicating. So on some of our earlier discussions, we talked about the importance of communicating what we're doing. So I brought Marty in, and now Marty and Courtney as a way to communicate, to capture those and help me with that, because I'm not any good at it.
Right.
Both of them are remarkable at it. So Marty has done these insight journals that have just it was a game changer for us up there. So I think for us to be successful, we cannot forget about, I don't want to say bragging about our work, but communicating what we can do and figuring out how do we communicate. So like I was talking to Andrew went with me on my last trip, and we did the Data Governance Council meeting where we showed the pilots. On the way home, I was saying, Andrew, how do we shine the light on all this data science work? Because if we keep it in the dark, no one knows about it, and no one will ever take advantage of it. So we have to bring it into the light.
Right. So
this podcast room, I think, is a step. Having podcasts, I think we need to do like vlogging. Andrew and his team need to communicate and write down all the really creative ideas and things that they're working on, and start building a community. And we have the KDD thing, the ACM knowledge discovery and data mining charter that we have here. That's just hanging. We got that started about a year ago. We haven't done a lot with it, but in order to communicate and shine the light on this thing, we can bring in the universities and the colleges here in the state and get them on board. They'll generate our next workforce. They're not only set up people to work in ITL, but work across the ERDI. And then if we really shine the light on it, I think the work will come. If we keep it in the dark, then we're going to have to go out and shake the trees to get the work. So I just don't think we can forget about the communication piece. That is, I look back at what we did with Data 25, bringing Marty and Courtney in. That was instrumental in the success that we've had with the program to this point.
Right.
It's putting that layer in. It's not about just doing the cool science. It's about communicating what you're doing and communicating your ideas and how do you do that. And we could take advantage of these new technologies to make it happen.
Right. Good deal. All right. So 30 years and you're doing? Well,
the number, it ends up being 30 and a half. But I got to keep add all my sick leave to it. So it ends up being over 32 years. So,
wow. Yep, 32 years.
So I had a lot of sick leave saved up. So just kind of looking back, I was thinking on the airplane yesterday coming in, I don't think I'd really change anything. All my degrees are in computer science. I think computer science is a remarkable field. It has a lot of, I think it's not just plug and chug with computer science. I think to be a really good computer scientist, you have to be creative about how you can use these fundamental tools to bend them and flip them and spin them in ways to solve these problems. So a lot of people may not know this. The thing that I really excelled in school, in high school and in junior high, was art. I painted. I got paintings that I've done as a kid and all that. And I've always enjoyed the drawing and stuff, right? So my dad always thought I would be an architect because I had a little of that behind me. But so when I first went to college, I actually majored in petroleum engineering because my dad always wanted his kids to be engineers, right? And I remember calling him one day and saying, Dad, I think I know what I want to do. And so he's going, oh, okay, you don't want to do petroleum, you want mechanical, electrical, whatever. I'm going, I want to be a computer scientist. And the phone went empty.
Yeah.
I mean, it was blank. And his question was, what is that? But it matched up to me perfect because I got the creative piece. I love the creative piece. And then the problem-solving piece. And those two worlds come together in computing. And now I got this AI thing, which is just remarkable. And it's just like this empty, open field of innovation that I can run in. And I just think that's going to be the biggest change that we'll see in computing after me and the next generation that works in ITL is what do we do with it? So that's the big question for ITL is how do we use AI to solve problems that are unsolvable today?
Right. Yep. Oh, no doubt. No doubt. AI will become a tool just like all other tools we have, and we'll use it every day. No doubt.
Yeah.
No doubt about it. Well, I think most people, so we've talked about 3 or 4 big impact things that you've done, and I think most people would consider that a successful career.
Yeah.
No doubt.
I've had fun. I wouldn't change. Like I said, I really look back. The only thing I would change is I would go back and address this whole communications thing. I would have probably written a lot more papers. I think I ended up with like 60-something papers. I think that's really cut myself short for what I could have put together. We could have put some patents out. Back then, doing patents with software was hard. I think it's still hard today.
Right.
But we were so focused on the impacting and writing software, we just left this whole component out of our world, and I wish I wouldn't have.
Right.
I think I would like to go back and fix that, but I don't have a time machine, so I'm stuck with what I got.
Gotcha. All right. Well, thanks for talking to us, and congratulations, and good luck in retirement.
All right. Thanks so much.
Okay.
Now I get to sign the wall.
Get to sign the wall.
Thanks, guys.